let's say you see this kind of a simple question in your chemistry JAMB exam. How will you solve it? This question is very simple. So let us quickly solve it together. The question says, if the electronic configuration of an element is 1s2, 2s2, 2p5, how many unpaired electrons are there? This question is very simple, and you can see the options. Now, what I feel like we need to understand is the term unpaired. Unpaired. What does it mean? The word unpaired. Unpaired means that something is not paired. It is not paired. And the word pair means that things that are in twos, like a pair of glasses, a pair of shoes. All of those things, they are in twos. That's the same way electrons too are in their shells and orbitals. Electrons are always in pairs, right? Electrons are always in pair, like two electrons. They are always in pair, just like this. One electron, another electron. Electrons are always in pairs. So now when they now say that an unpaired electron, that means one electron that is standing on its own that does not have a partner. That means that if you have something like this, just like this is an unpaired electron. You understand? If you have this something like this is a paired electron. It has a partner, two. But if it is unpaired, that means it's only one. So anytime I say an unpaired electron, you should know I'm talking about something like this. So now, let us quickly move to the main question. You can see the question. You can see the electronic configuration. So this electronic configuration, let's try to arrange these electrons into their respective orbitals. You see, these two electrons here, they are in the first orbital, of course. They are in the s orbital, they are in the first shell. This is second shell, s orbital, second shell, p orbital, you understand? So now, let us try to draw it. I want you to know that something, the orbitals, the SPDF orbitals, sharp, principal, diffuse, and fundamental. This S can only take two electrons. So you have something like this. It can only take two electrons, right? This is for S. Sorry. This S can only take two electrons. So you have something like this, right? P can only take 6 electrons. So you have something like this. Hope you are following me. I'm filling them in. You have something like this, right? D can only take 10 electrons. You have something like this. 1, 2, 3. Can only take 10 electrons. You have something like this. Hope you are following me. All of these things are paired though. Then F can only take 14 electrons. Something like this, 2 sharp, but that one is 14. So let us continue now. So now let us put our own electronic configuration into their orbitals. So let's start. This is 1s2, right? So 1s2. Let me put it into its orbitals, right? 1s2. 2 electrons, they are there. You see, 2s2. 2s2, right? This is still the s orbital, right? 2 and 2 electrons are there, 2s2. Now, 2p5. 2p5. So this is p, of course. This will be it. So you have something like this. 1, 2. So this is 5, right? So 1, 2, 3, 4, 5. So now you can see this is a paired electron. This is a paired electron. Is this one that is standing on its own? This is an unpaired electron. You know, get partner. Hey, do you get the gist now? This does not have a partner. So what does this answer? What is the answer is going to be? What is the answer? They say how many unpaired electrons are there? How many? Just 1. So the correct answer to this question is 1. I believe this is very simple to understand. If you have any kind of question like this, you can always use this rule and you'll be able to get your answer. So now let me give you an assignment. So if you have an electronic configuration like 1s2, 2s2, 2p6, and then 3s1. How many unpaired electrons are in an element with this electronic configuration? Drop your answers in the comments and I'll be there to look for the correct answer. I'll see you guys in the next one. Peace out.